Now in this video, I'm just going to show how to calculate one correlation coefficient, or something referred to in statistics as Rho. Now, earlier, if you watched the video on standalone risk, you saw an example of me doing a portfolio's expected return, which was nothing more than the weighted average of the expected returns of each of the individual stocks. And that's the same example from the video. It's there in the green box. And we see that the expected return for these four stocks using historic data, expected returns is 10.25%. However, in order to determine the risk, you can't just take the weighted average of each of the standard deviations. When we put two stocks together, like if you read the notes for this week, the risk will always be lower except in one case. That's if the two stocks are perfectly positively correlated. So we're going to calculate this correlation coefficient in this gray box here. Now I'm going to use just two data points, X and Y. Before I go any further, I just want to make sure everybody understands what correlation coefficient means. It just tells me the tendency of variables to move together or not, kind of a relationship. I use the example sometimes that I can plot a graph of maybe numbers of beers consumed the night before the exam and the exam scores, and I'd probably see that the more beers consumed would lower the exam, so those would be more negatively correlated. Or perhaps I could do a more positive correlation, a number closer to 1, and the more hours spent studying for the exam, the higher the grades. Now those would tend to move together. Now that would be more positively correlated. So here's the quick example. Look over here. You'll see two data points, X and Y. And I'm going to do this longhand only once, and then we'll use Excel. X and Y. Now you can eye the data point and see there is maybe some relationship between the two, because the first one's 3 and 4, and then 3 goes down to 1, and 4 stays the same, and then it goes back up 1 to 3, and then this Y goes from 4 to 8. So it looks like there's some relationship there. But let's go ahead and find the number that we can understand what the relationship really is. So we see X and Y. Now I'm going to add up all my X points, and I get 16. All my Y points, I get 24. Then I'm going to take the average, or X bar, or mu. So if there's 4 data points, divide that into 16, I get 4 and 6. Here are these numbers right here. And for later on the problem, just below that in orange, 3.464 and 2.309, I went ahead and got the standard deviation as well. You can do this really simply in Excel. The video on the standalone risk shows you how to calculate that. So we have the standard deviation and the average, or mu, of X and Y. Now I'm going to go over and look at X minus X average. So I'm going to just take the X bar of X and subtract it from each data point. So if you look, 4 from 3 gives me -1, and 4 from 1 gives me -3, and you go down, I have a -1 and 5. There's that data point. I do the same thing for the Y. So if I take the 6 from 4, I get a -2, and the 4 from 6, or the 6 from a 4, I get a -2, and so on and so forth. Now I'm going to multiply them together, the product of the two, which is the last column. So -1 times a -2 gives me a +2. And I get the 6 and the 2 and the 10. So if you look, here's the covariance formula. So it says I have to sum up or add all the XY products. So if I add the 2 and the 6 and the -2 and the 10, I get 16. Now, this is not a population, it's a sample, so I'm going to divide that by n-1 because of degrees of freedom. So if I divide the n-1, which is 4 minus 1, 3, 3 into 16 gives me the 5.333. And what's interesting here, when we were doing variances on the last video, I showed that the variance is not in the same units of the FICO score we were using, so I had to take its square root, get its standard deviation, to put it in the units. And it's different here because the covariation is actually in the units, and I don't want it in the units. I want it as a number between -1 and 1. So how do I do that? Well, I take my covariance, which is the 5.333, and I divide it by the product of the two standard deviations, the 3.464 and the 2.309. Multiply them together and I get 7.998. So now I'm going to populate a cell here, and I'm just going to go ahead and say equals And I'm going to put the 5.333 here, and I'm going to divide that by the 7.998, and I'm going to get a number that looks about, what is that, 6.666, ooh, it's an evil number, 6.67. So it shows me the data points are moving together, but not perfectly correlated. Perfectly correlated would be 1, and again, a perfectly correlated stock would lower the risk. No, it would not lower the risk at all. So I want to move it down. So I'm going to do one in Excel. Show how easy it is with Excel. Now here I've got, in these two boxes here, I got two stocks returns. So in this kind of the burnt or red and the orange, I can see that this year this stock did 110% return, whereas the second stock lost 80%. This stock dropped to 22%, and this one actually went up to 8%, and this one dropped down to negative 60%. This one dropped to went up to 90%. So you can see it's kind of like the beers consumed in the grades. As one went up, the other one went down. So you can see there's some correlation. They do move together, and they tend to move in the opposite. So we're looking closer to the negative one, which is what we'd like to have to eliminate all risk. So in order to do this in Excel, all I have to do is go to Formulas and More Functions and Statistics. And all I need is my two data points, and I find this called Core, C-O-R-R-E-L, and then I grab my first set of points. Here they are. And then I'm going to put my second set of points. Here they are. And it is actually a perfectly negatively correlated two stocks, which would be a wonderful investment if you were to put those two stocks together. You eliminate the risk. And I can go ahead, if I'd like, I could do this one as well here. Let's see if I can go ahead and mimic this one by trying it one more time. Formulas, More Function, Statistics. And I can tell you right now, and I've done this with the TI-84, it takes about 40 keystrokes. So I recommend, if you can use Excel, I would always use Excel. And yep, we reproduced that number here as well. So we actually did it correctly, longhand and with Excel. And like I said, Excel is much easier to use. Now I'm going to travel down here and just want to look at this last picture here. Now, these are two stocks, Amgen and Altria, and you can see the red line would represent if they were perfectly correlated. But as I find two stocks that the correlation goes from 1 to 0 to negative 1, I'm stretching that line to blue to black. So what I'm doing is I'm lowering the risk as I'm increasing my return. And that is the basis of the modern portfolio theory that was I guess designated by Harry Markowitz back in 1952.